This is Cosmographia, the Randall Carlson podcast.
Welcome back, ladies and gentlemen. This is Cosmographia, the Randall Carlson podcast, episode 105. And we are back in studio. We're going to continue on with Randall. Were we still talking about the sun?
We were talking about the sun. Yeah, it changes in the sun. Yes, we were. And we could pick up on that theme. Been kind of focusing, we focus so much time on the late glacial maximum, the younger Dryas period to transition out. And I've always felt like I've been neglecting the Holocene. But now since I've been working with you guys, and you guys are the Holocene working group.
We are. The Holocene, yeah.
I feel like that it's time to remedy that neglect and look further into it. So I think, weren't we talking about the sun kind of in the context of some of the changes that we've actually seen during the Holocene?
Yes.
Yeah.
That's right. Yeah.
Yeah. And that's worth looking into in more detail because, God, there's so much interesting stuff coming out that nobody was even imagining 10 years ago. That's really confirming what I would call the dynamic model of Earth history rather than the stable model of Earth history. Now, of course, what I think the record that we're now putting together shows that there are periods of stability, of course. But they are quite frequently, as it turns out, interrupted by various kinds of convulsions and upheavals and disasters and catastrophes and cataclysms and what have you.
So I have a question about this because in general, the millions of layers that you'll see, especially in sedimentary rocks, a lot of times, each one of those layers, maybe a small layer, will be considered it encompasses a large amount of time.
Mm-hmm.
But does incorporating more and more catastrophic events in Earth's history, would that shrink that time or make those layers actually many of them put down quickly and so they don't represent as much time?
Oh, sure. And
does that mean that stratigraphic style dating would have to be completely reworked in some cases?
No, I don't. Well, in some cases, perhaps, yes. I don't think overall. I mean, because you've got the succession of layers there that represent different time periods, and they can be correlated over vast geographic areas, essentially by the fossils that are found in them.
Right, but how are the fossils dated?
Well,
right?
That's up to this point, up until recently, those fossils were dated by essentially just guesswork.
Okay.
You had let's see, what was it? You've got an absolute time chronology, and then you've got a relative time chronology. So
yeah,
the first thing that happened in the first century or so of geology or more is that this relative stratigraphy was worked out. And of course, it's constantly being refined and improved, and they have these conferences quite regularly where they want to update the geological time record. And perhaps, one of the most recent things is making those adjustments to what we used to call the Cretaceous Tertiary boundary, now to the Cretaceous Paleogene boundary, because they've been tweaking and adjusting the periods in there. So I'm still, for me, it's still the Cretaceous Tertiary, the KT boundary.
Right.
Because they've gone to the Cretaceous Paleogene, now it's K and then a capitalized P and a small case G. And that just, to me, is getting way too complicated there, Dad.
The KPG,
let's just keep it KT, damn it. Not this KPG thing. But
So across the world, you can correlate different layers by saying, this layer over here on this continent has these fossils in it. And over here on a completely different continent, we see the same fossils. So we can say these must be from the same time period since they have the same life form.
Yeah. And what now is, before the idea was you looked at the various periods in geological history, and there were the things called disconformities and unconformities. Let's see if I've got this. I used to know this, but Kyle, would you look up the word disconformity? And there's
all right.
So what happens is that you'll have a layer, and then a lot of it gets eroded away, and there might be this gap in the rock record. So what is now a thin layer may not have originally been a thin layer, may have been much thicker. And due to a disconformity or an unconformity.
A disconformity. It's a buried erosional or non-deposition surface or boundary between parallel rock layers of different ages.
Yeah, so say the first part again?
A buried erosional or non-deposition surface.
Okay. A buried
or boundary.
Yeah. So what I was just describing then would have been a disconformity. So it's been eroded. So the surface that is there was not the original surface. So now you have another deposition layer on top of that. And so you've got some indeterminate hiatus of time that transpired there that you can't work out. But here's the thing. You may have this succession. And if you can see, you go this limestone layer with certain ages of certain kinds of fossils, and then that becomes a layer of sandstone, and then that becomes a layer of shale. Well, you can kind of figure out there that, well, you go from limestone to sandstone to shale, you're looking at a rising sea level. And then you might see something, that now includes what would be terrigenous sediments, which is stuff that's coming from land, right? So now you know that the sea level is going back down. If you've got shale is going to be very prevalent in a near shore or coastal type environment where you have a lot of swampy type stuff. Like if you're out on the coastal plain in the southeast, or down in the Delta region of Louisiana, along the Gulf Coast, places like that, you're going to see you've got a lot of swamps, a lot of marshes, and so they tend to produce shale, often shale with plant fossils still in them, right? But where you get a muddy type of deposit, and then it might shift to sand, and then it might shift to limestone. Well, that's what would happen if you've got the sea there, limestone is being formed, and then you've got a beach with sand, right? And then the sea level rises, and so now that sandstone will become, depending on how long the sea is up at that level, now it'll begin to deposit calcium carbonate-based stuff that forms limestone. So now you got a sandstone with a limestone, and then let's say that the sea level goes back down. So then you're going to have more sandstone, and it keeps going down, and so the coast is following, the land, the terrigenous stuff is following the coastline, so now you have land over that. So you go through those succession of fossils like that. So now you go and somewhere 1,000 miles away, you see, oh, look, here's the limestone with the same fossils in it, and then it's got that similar sandstone over it, and you can see the same succession. And so now you correlate, and you kind of do that piece by piece going around, and eventually now they've worked out or are in the process of working out. And this comes under the heading of historical geology. That's what this would be called, historical geology. I will admit, I'm rusty on my historical geology, even though I took courses in it. That was 30 years ago. And I don't use structural geology unless it's a specific, like if we're going to go do a tour, now there we're going to look at a lot of that historical geology because, when we were doing the Cumberland tour, or when we do the tours out west, we do scab lands now. It's all pretty much all basalt, right?
Right. And you've told us in the scablands, for example, how old that basalt is supposed to be. So how are they checking that? Are they doing radiometric dating of some kind?
There is, yes, radiometric dating, and we're going to have to do a special episode, a special edition at some point where we talk about just dating. And I know you got a lot of good stuff, and you've studied into some of the dating. And, the dating methodology is constantly evolving.
Yeah.
And I'm behind on it. I need to catch up on some of the new types of dating and how they're corroborating and calibrating those dates. But But they are. There's various ways you have to check and cross-check dates to understand if these are actually accurate depictions. And of course, some of those datings, the radioactive dating from the various rocks and minerals, that can have a pretty wide plus and minus range.
Yeah, it's a huge margin of error. And
right,
in general, the older it is, the wider the margin. It's a percentage-based thing.
It's yeah. However, now, like with the KT boundary, the Cretaceous Paleogene boundary, that has been refined to 65 plus million years ago to like 66.6 million years. So now we're getting pretty precise to date that Cretaceous Tertiary layer.
Precision to within a million years.
Did you say 666?
Hey, Kyle, come on now. Let's.
Too many jokes, too fast, too soon.
Right,
okay, sorry.
I was just processing the first joke, and then suddenly I was assaulted with the second joke. So,
yeah, I'm just interested in this concept of, if we have to, if the understanding of climate, the effect of the sun on the Earth, the amount of impacts and bolide explosions that the Earth gets, if that increases, and that shows that there's been more catastrophes, then I'm just interested in how that will shift or change the appearance of the age of the dating of some of these layers. I mean, obviously, it's not going to have effect on the magma stuff so much, but it is going to change ideas about the sedimentary stuff, because you can have enormous amounts of sediment moved in very short amount of time,
right?
In a catastrophic event, and it might look like something that took millions and millions of years to lay down, but it's actually was laid down in 2 weeks or a month or maybe 100 years, right?
Yes. And one of the things I was going to try to point I was going to make is kind of the shifting in the way you look at that stratigraphy, is that early on the idea was it was not assumed that catastrophic events were global in extent, that they were just regional. Now, how that affects the thinking is this: if it's just regional and you're seeing a cataclysm that's just in a local or a regional area, it has no bearing on the global synthesis, right? Whereas if it's a global catastrophe, it's going to, it essentially by definition, and is leaving an imprint all over the planet. Now that becomes a datum that can be used to correlate things on a broad scale, and has just the opposite effect of a local catastrophe that's going to disrupt and confuse the issue of trying to correlate strata across great distances. See? And that's part of what has happened, say, since the 1980s, 1990s, is the recognition of global scale events and the incorporation of that into one's thinking about chronostratigraphy, which is the whole process of dating. So now it's recognized, well, yeah, if you have global events like the KT iridium layer is global in extent. So wherever you can find that, that now you're looking at a synchronous. This layer in New Zealand was laid down at the same time as this corresponding layer in Denmark, and this one in Italy, or this one now in China, or wherever it happens to be. So now you've got this widespread global datum that you can use that becomes a major reference, rather than the difference being that if it was just a local catastrophe, then any kind of correlating you did anywhere else with that is actually going to introduce more error into your models of the chronology, right? Does that make sense?
Yes.
Okay, so what that entailed then was a shift, whereas if you've got a strata, however thick it is, from a few feet to maybe even hundreds of feet, and it's clear that you've got a disconformity or an unconformity or something happened that bookends that, right? And your assumption is that those are probably just regional events that are only going to be visible at this particular fascia, at this particular outcrop, at this particular place. So what you do is you don't look at those, you look at the middle, where you're trying to focus on the part of the strata where nothing was happening out of the ordinary. Whereas now we're in a different position because since the last, say, 30 to 40 years, there's been a much greater recognition of global scale events. So now the focus is shifting away from looking at the places within a stratigraphic section where nothing happened to the points in the column where something happened. See? And that's a major shift in how we think about the Earth. And I think there's probably an old school of geology that's still, looking at that gradualistic mode primarily, but like you just were talking about, Russ, I mean, that's the recognition that we're at now is that, yeah, there are these events that vastly accelerate the process, whether it's a depositional process or whether it's an erosional process. And of course, they're correlated because if you've got a major erosional event, that means that forces of nature, probably water being the primary one, are removing material from one area and putting it somewhere else. So a major erosional event will often coincide or correlate with a major depositional event, exactly as the kind of thing we've been seeing in our tours in the Scablands and so on.
What was it? Unconformity is what you said?
The other one was unconformity. And there's a slight variation difference in the meaning. And if Kyle would be so good as to look up the unconformity.
So what was the first one? Disconformity. Okay. Because I think because here where we live, the Edwards Plateau area, it's an uplifted. Go ahead.
Unconformity is a break in the geologic record caused by a period of erosion or a pause in sediment accumulation, followed by the deposition of sediments anew.
How is that different from disconformity?
I'm
going
followed by more sediments being deposited.
A pause in sediment accumulation.
Rather than erosional.
Followed by the deposition of sediments.
A pause rather than an erosional event.
But it does say a break in the geologic record caused by a period of erosion or a pause.
Yeah. Sounds like close. It's the same material where the disconformity was then overlain by a different material.
This says, the other one is a buried erosional or non-deposition surface or boundary between parallel rock layers of different ages.
So it has to be buried. So so here we have Glen Rose Formation is exposed in a lot of places, and that's like lower Cretaceous.
Okay.
But it is the surface now in a lot of places.
Yeah. So that means that a lot of stuff post-Cretaceous is gone. Yeah.
Yes. Because if you go off the plateau, right, and into the lowlands surrounding it, it's all that material is there, and so the plateau would lift it up, and then all this stuff washed off of it, and it's been continuously washed down, and it's gradually going back in time as it wears the layers down.
Mm-hmm. Okay, so a disconformity is an unconformity. A disconformity is an unconformity. This is from Wikipedia now.
Okay.
Between parallel layers of sedimentary rocks, which represents a period of erosion or non-deposition. Disconformities are marked by features of subaerial erosion. Okay, so subaerial erosion as opposed to submarine erosion. Subaerial means that it's in the air.
Under the air.
Yeah.
Under the air, yes. Okay, this type of erosion can leave channels and paleosols in the rock record. Channels because water's been flowing over it, and paleosols are basically ancient soils.
Okay.
A paleosol would be an old and an ancient soil. In general, the older layer was exposed to erosion for an interval of time before deposition of the younger layer. But the term is used to describe any break in the sedimentary geologic record. The significance of angular unconformity, see below, was shown by James Hutton, who found examples of Hutton's unconformity at Jedburgh in 1787 and at Sticker Point in Berwickshire, both in Scotland. The rocks above an unconformity are younger than the rocks beneath, obviously, unless the sequence has been overturned. Now that's interesting in itself, is how sequences of rocks become overturned. Now, obviously, we do know, we see there, on our trips to Meteor Crater, there are sequences of rocks that have been overturned. How would you overturn rocks, layers of rocks, without an impact?
It'd have to be an earthquake.
Yeah, tectonic activity.
It would have to be tectonic activity, but doesn't that imply then, if it's slow, I mean, literally, it would have to be compression, not tension. It can't be plates moving apart. It can't be a rift. It has to be compression.
Well,
okay.
Could be a rift because you could have pieces that fall into it and flip over, and then later that surface is eroded away. I mean, that would be a little more.
Is that possible?
Well, we have seen the ones that, like at the Scablands, their cliff faces drop away and they turn this way as they fall.
Yeah.
They don't flip over completely, but they do.
There's a name for that.
And we had that. We struggled with that. I found the name. God, it's right. It's right here. It's between just under a few layers of skin, right here.
It's in a unconformity in there somewhere.
No. I think it's a disconformity.
Disconformity okay. All right. Well, we can go back to the Holocene. I just wanted to ask those questions. Didn't mean to distract too much.
Well,
from the
I mean,
topic.
it's okay because maybe the listeners wouldn't find that as interesting as I do, but I do find that just very interesting. So
yeah.
But I do now see there's a whole, okay, good Lord. Okay, so there is a disconformity as well as a nonconformity, and there's also an angular unconformity, and I think that could be along the lines of what Kyle was envisioning. But there's also a paraconformity, and a buttress unconformity, and a blended unconformity.
Blended.
Oh my God.
Blended.
Gotta throw a blender in there, of course.
A blended unconformity is simply a type of disconformity or nonconformity with no distinct separation plane or contact. Okay. It can sometimes consist of soils, paleosols, right? Ancient soils, or beds of pebbles. Okay. And they've got pictures, and I'll do this on my own, but I'm going to get up to speed on this because, when I came out of historic geology, I was pretty good, on the final exam. We were given 100 fossils that we had to identify. We had to identify the entire stratigraphic column, and I don't remember what all, but I did ace. I aced it. I could identify all the fossils up to maybe a couple that I missed. I had the whole geological column memorized in my mind, all of the most recent dating and everything. Of course, that's changed somewhat too in 30 years, more than 30 years. Anyways, so the Holocene, now we have this date for the beginning of the Holocene, which is such an interesting date that we talked about many times. What is that date for the bottom of the Holocene?
It's like 11,800 or 11,006.
11.6 to 11.7. I think I've seen it both as 11.6 and 11.7. And we know that the event, there was a climatic event, there was a very rapid warming that occurred, and there was meltwater pulse 1b, which occurred. And it was probably the final stage of the megafaunal extinction. This is something that, again, I think we're just, what species of megafauna? We know some survived the younger Dryas, but what species and what extent did they survive? We know that mammoths survived the younger Dryas, but they were in a very isolated condition. They were on islands that forced a a reduction in the size of mammoths into pygmy mammoths. The mammoths that survived the younger Dryas became pygmy mammoths after X number of generations. And they were like half the size of their pre-younger Dryas ancestors. But so the question is how, again, all of those things are still being worked out, still being debated, the precise chronology and intercorrelation of these different events. Sea level rise, the deposition of the younger Dryas proxies, the disappearance of the Clovis culture, which came up in our last live episode because we were talking about those footprints down in New Mexico on Lake Otero, I guess it was called, the Playa Lake that has since desiccated, and there was 2,000 years of sedimentary, remember what we had, let's review, 7 sedimentary layers that had tracks on them spanning a time of 2,000 years. And they dated, that 2,000 years is dated between 21 and 23,000 with some room for wiggling in there. So this was definitely pre-Holocene. You're still Pleistocene there. And we talked about how, how interesting that is to think about and try to reconstruct in our minds. Well, what was going on? So there were a lot of people, apparently, quite a few people. Walking on the shores of a lake there 22,000 years ago. Where else were the people? Around North America. And so we're late glacial maximum. So we know that if you went up to, think about our trips to Montana and to Washington, we've been right up at the glacier margin where it would have been during the late glacial maximum. Flathead Lake and Polson Moraine. That would have been the southern extent of the Cordilleran ice sheet, which presumably was more or less correlated in time with the Laurentide ice sheet. There's some evidence to suggest there was a lag, so maybe the Cordilleran ice sheet didn't form somewhat like a millennia or two after, didn't reach its maximum extent until somewhat after the Laurentide. But in any case, we're looking at an inhabited, unglaciated North America 22,000 years ago, more than 10,000 years or 10,000 years before the younger Dryas, 10,000 years before the Clovis. So who the hell were these people? And where did they come from? And where did they go? Was there continuous question in my mind? Was there continuous occupation between those people and the Clovis, who were also occupying? Remember now, the Clovis were occupying areas very close, right? Because we find, Clovis sites in New Mexico. However, the Clovis people are there, 10,000 years later. So now, was there a continuous habitation in there, or did those earlier people then disappear and there was nobody, and then there was a reoccupation? I don't know. Does anybody know?
I don't know.
But what an interest.
I would like to know what lithics they're finding associated with those white sands prints. Because the Clovis, we talk about the Clovis people, but that's really a lithic style. So it's,
man, that would be awesome if there was. I haven't heard anything about.
Yeah, that's what I'm saying.
Their tools.
There's no mention of tools. Right. It's all about the footprints.
There's got to be tools buried in those same sediments. I'm sure somebody dropped a spear.
Yeah.
In the lake. Somebody stepped on it.
You would think. Well, maybe, just maybe. Now with this kind of, just like what's his our buddy over at on the Savannah River, Dr. Goodyear. Like he said when we were out there looking at that Clovis site out there. Topper. Thanks, Brad. Topper, Dr. Al Goodyear, we were out at the Topper site with him, and he was basically telling us that, for years he was just looking at the Clovis, and people would ask him, well, then what's under the Clovis? And he said, well, nothing. He just assumed, like they did across the board.
There's nowhere to dig,
Yeah, so there's no, but when he finally did, what did he find? He found, I guess, lithics, if I remember
previous
right.
layers of lithics.
Yeah, that went back how far?
Oh, it was Topper. 20?
20?
I don't remember.
I'll look it up.
Yeah.
I thought it was 20 something thousand, 20. I'll look it up.
Well, see, then that would
I would
correlate.
say 26, but yeah, that's a guess. It was 20
That
plus
kind
for
of puts
sure.
it then in the same time frame as the Lake Otero footprints.
They were at the end of the age of Aquarius.
I thought this was the dawning of the age of Aquarius.
Well, I guess they would have been.
Oh, you're saying that would have been
round
the. Well, yeah, you're right. You're right. So,
like it would have been maybe Capricorn.
The website Wikipedia says
50,000.
Whoa,
50,000.
Well, it
Okay.
says the primary dig has gone down to at least 50,000, but artifacts may predate Clovis by 3,000 years or more. But conclusions are disputed.
Yeah.
Right.
So Goodyear argues that the deepest layer has carbonized plant remains, which he argues is a fire pit, dated at 50,000 years old.
Okay. So the difference here then is the evidence itself. So the evidence at Topper is being disputed, and you can argue it both ways, I guess. Because 50,000, I'm inclined to believe that there were people 50,000, but that's not quite the same in terms of confirmation of the existence of people as footprints.
right.
It's pretty obvious.
Depending on the lithics, it can get pretty sketchy too. I mean, like
it can, yeah. And
there's these people are arguing whether these flint chunks could have been broken in certain ways by grinding when they're really primitive points.
Yeah.
Kind of hard to tell.
Yeah, they start calling them geofacts.
Yeah, geofacts.
Instead of artifacts. They're like, oh, well, a glacier could slide along just so and break the flint where it kind of looks like a unifacial.
The thing that really doesn't make sense, though, is when they're concentrated in like a little area, like a campsite.
Yeah.
That's next to a creek.
Yeah.
Like, come on.
Right, where they're doing their napping and their flinting and all of that, you're going to find the debitage there concentrated.
Yes.
Now, if you can find that correlated perhaps with what looks like a fire pit or some kind of habitation,
burnt rocks.
Right.
Yeah.
So, like Russ, you were saying earlier, I mean, the farther back you go, the sketchier the evidence becomes.
Yes.
What we need is we need human remains. But that's the thing we talked about last week. Where the hell are the people? We've got thousands and thousands of woolly mammoths and megafaunal animals that have been found in various states. Just like, Kyle was saying, you would expect that just like somebody dropping a spear, somebody's going to die and fall in a crevice and get frozen in, and we're going to find something, or they're going to get caught in a flood, flash flood. But where is the human remains? Like, where are the Clovis remains? So we see their campsites all over the damn continent, unglaciated North America, but where are their remains?
Yeah, I wonder if this is part of the argument for there being just very few people. There were millions of mammoths, there weren't that many humans, and that's why their remains have not been found.
And yet the humans killed them all.
Right.
Yeah, I was going to say, right. Exactly. What does that say about the overkill?
Yeah.
If that's the case.
Speaking of mammoths, how did they get out to Catalina Island? I know this is kind of going, this is a tangent, but how the hell did they get out there? I mean, is this a valid question? Did they swim?
Fur floats.
Well, elephants can swim.
That's pretty far.
Swim.
Yeah, that's pretty far, though. In the water, I mean, I looked it up. The water gets like half a mile deep, so there's no chance there was a walkway.
Right.
With a 400-foot drop in sea levels. I mean, seems kind of far to swim, but maybe. But, enough of them swam out there to where you have a population that can get small.
They were shipped out there.
Yeah,
Come on.
I know. That's what I'm saying.
They were imported.
I remember after the Atlantis presentation, and I was presenting the argument that geologically Atlantis isn't so far-fetched. That was the I think the takeaway of that, it looks like we have a subsided landmass in the middle of the Atlantic Ocean, and it dated to the appropriate time when it would have been above sea level, and it would have been a very benign climate. So, then the question is, how did people get there? Well, obviously they had navigational skills, because we know that there were islands inhabited by people going back 50,000 years ago. So people were beginning to develop the seafaring skills really long time ago, right? But then, as Plato says, there were a lot of elephants in Atlantis. So then somebody, I remember, posted a comment and said, well, that
must have been mammoths.
Well, it's like, well, okay. Well, the argument was, I think this came up in the controversy with the recat structure.
Okay.
Because the recat structure could have had elephants, but the argument was these elephants couldn't swim out to the middle of the Atlantic Ocean. Right. And I pretty much, I agree with that, but we're talking about a major maritime culture here with navigational skill and ships.
Yeah.
They bring some mating pairs of elephants. That's,
all you need.
That's all you need.
Yeah.
And, if you're, they were doing this tremendous, the infrastructure that he describes, whether that's literally true or an accurate, I think it's very possible that they were conducting massive engineering projects.
Yeah.
Which we know early man did, because the evidence of that is everywhere.
Yeah.
So, and if they were doing that, perhaps elephants might have been handy in moving 10 tons.
Beasts of burden.
Beasts of burden.
But so are you telling me that somebody put mammoths on a ship to bring them out to Catalina Island? Is that what you're saying?
Hey, Neanderthals were apparently sailing around 100,000
100,000 years ago. Yeah.
Well,
I mean, maybe what if you would just decide to ride it out there? If you can ride it, then you just get on it. You tell it, let's go out into the water.
Okay. Well, let me ask you this. Was Catalina, is there any evidence that Catalina Island was inhabited?
Yeah, there's burial sites there, and some of them are very interesting. I don't know if they're considered to be contemporary with the mammoths, but yeah.
Well, so that if they're contemporary with the mammoths, then I'd say that.
I was saying I don't think they're considered to be contemporary with the mammoths.
Okay.
I don't know. I don't remember, but we did go over some Catalina Island burials that are very interesting.
They're not Clovis then, in it.
I don't know.
Okay.
I would have to check. Yeah.
Okay. Well, let's see the Channel Islands, Santa Rosa. Now, megafaunal remains have been found on Santa Rosa Island, along with human. I think they found a skeleton of a girl there. Am I remembering that right?
Yeah.
Now, I'm not seeing the bathymetry here. I don't have Google Earth open, but Santa Rosa in the Channel Islands National Park. Now, that was inhabited.
Channel Islands. That's
seems like you guys had checked in something that there was like evidence of elephants swimming a mile out to islands off of India or something.
Yeah.
But yeah, I don't know how far. Catalina's farther than that for sure, but yeah, Santa Rosa might have been fairly close with the sea level difference. 8
complete human skeletons, 250 skulls, 9,500 human teeth, and fragments of bones numbering almost 3,000 persons now repose in the Glidden Catalina Indian Museum, with many other articles of historic importance.
Huh.
Well, that's where all the Clovis went. There you go.
And so I'm looking here. It looks like Catalina Island is about 30 miles off the...
That's pretty far.
Yeah. Of course, now, wouldn't have been that far with sea level down, but you're saying that the depth of the ocean between Catalina and the west coast of California there, south of Los Angeles, gets a mile deep, is what you said?
3,000 feet is the deepest.
Yeah, there's a huge submarine canyon out there.
Yeah.
Okay. I just might have to open Google Earth.
But I was trying to just look up like how deep does it get? But then it occurred to me that maybe there's a part that gets that deep, but there could be a shallow area that you could have walked on. I don't know. I'd have to look at the. Anyway, it was just an aside question. How did they get out there?
That's
Well,
two
I'm
aside
looking at-
questions,
Two aside
and we're
questions,
already
yeah.
almost 45 minutes in.
Oh yeah, I said,
Listen,
man,
this is
look at
important
this.
research, guys.
Well, I mean, these are interesting questions.
It's been interesting. I agree.
There is a very deep channel. Wow, minus 11,000 feet.
Whoa.
But it would be relatively narrow, though. So with sea level down, if we could do this just for laughs here, I will we'll do a share screen and so here I've got Google Earth Pro open, and let's see, Catalina. Back up here.
That's directly out from like Laguna Beach there, south of LA.
Yeah. Wow, that's some pretty wild seafloor topography
Yeah,
there.
that's wild looking. Yeah. Mountainous.
Yeah, look at that. Wow. So let's see. I believe this is Catalina here. Or is it no, it's
Yeah,
this
I think
one.
it's that one. Yeah.
That's that one. Right.
Okay, that's a big, deep channel right there.
So that right there is 2,850, 29. So yeah, almost 3,000 feet down here.
So how wide is it from the edge of the shelf there to the island? Assuming that's what they
it's
had
like
to swim.
halfway out.
Yeah, so 15 miles maybe.
Let's see, miles. Could do this. That's about 24 miles across there.
Oh, that's a
So
swim.
that'd been quite a swim.
Yeah.
Now you're assuming that this was a canyon back then. If you look at that, it may have been eroded out. If you look at the topography there.
By water
Well-
coming from up north
Yeah.
Or
Well,
or
it may have all
like
been
tides
tectonic
or something.
changes.
Yeah, it may have been all been carved out. You've also got a short distance here. But this may have been above water here.
We can't see where you're pointing, Mike.
Oh yeah, sorry. Go to the north.
go north. You
Go
can see
north.
my cursor, right?
Yep.
Okay. I'm all the way up.
Pull the map down.
Okay.
Over here to the left.
Oh, I see. Yeah, there's a
There's
What
a
is that, like a
this if
seam
this
out?
was if this was above water, there's a short jaunt across there.
Okay. So right here where I'm hovering over this prominence here, it's minus 2,300. And then when I go here,
that's still pretty deep.
Yeah.
we're minus 20, almost 26. And so there's about a 300-foot difference here. But all of it would have been underwater. But yeah, I mean, obviously, well, look at this.
Yeah.
Look at that.
That's what I was talking about, erosion. Man, look, you've got
That's like
looks you have
water
massive
poured
erosion.
off the edge there. and
Well,
into the-
yeah, it sure does. Look at this.
Yeah.
All right. So now, okay, you guys, now once you get certified, here's your first assignment.
3,000
Hey,
feet.
you want us to dive there? Yeah. 3,000 feet, no
You
problem, bro.
guys go and check this out. We need to know.
Randall, our
yeah.
open water course certifies us to 60 feet.
Yeah, and there'll be 60-foot waves on top of that.
Yeah.
I don't know.
Okay. It just more and more, it just seems like we're going to have to
Get
bite the
underwater.
bullet and get a submersible,
Yeah. Yeah.
but not one that's made out of carbon fiber. Okay.
Right. But I can control it with a Logitech
Yes.
game controller.
'Cause you
as
are-
long as it's made out of the right material.
Yeah.
Yeah.
Yeah. So look at this. My God. So look, it even looks like we've got like eroded recessional cataracts, doesn't it?
Yes, it does.
Look at that.
Yeah.
So is that, I mean, it does look like we've major pouring off right here. What? Okay. So now if we go up, well, look, so here you've got, is this channel embankments here?
Yeah, I can't tell.
You got water pouring off. You've got, this is Okay, that's 83 feet above sea level. And then you get right into the mountains here. We're, that's 1,500 feet. Over here, we got 600 feet. So say 500. So you could have a channel here that's 500 feet deep. And let me grab the ruler here. Miles. Okay. So about 6 miles wide there. But we also look like we could have something coming up this way.
What's that big right angle there? That's got to be some kind of artifact. That's very unnatural.
Which
out there
directly
off the
left
coastline.
off the coast, yeah.
Yeah.
Oh, this?
Yeah.
Yeah.
That just looks like
those look like scanning artifacts to me. Yeah.
Yeah.
I think so.
Yeah, it's got to be.
Yeah.
Oh, it went away, yeah.
Yep, there's
So
detailed scans.
you have a high resolution scan that's in a big rectangle there.
Uh-huh. Yeah. So Brad, for a moment there, thought he had discovered an underwater civilization off the coast of. He had this moment of elation there.
Not a literal artifact, but an artifact of the bathymetry data. Yeah.
All right. Well, these have been interesting questions. We don't have any answers, so maybe we should move back to the Holocene again,
where there are also no answers.
There are also no answers and still more questions.
Well, we might as well.
We can take a
cruise
break
around before the break here,
time.
yeah, because it's about break time.
Okay,
no shortage of fascinating stuff to look off the coast.
Really? Yeah. So then, all right. Well, yeah. I guess I'll go hit the restroom for a second, and then we can continue. I mean, I've got some good stuff pulled up here.
Okay. Cool. Well, we will take a short break and be right back.
All right.
All right, we're back, ladies and gentlemen. Back on track. We're not going past the Holocene, right?
Yeah, we're going to confine we're going to pretty much try to summarize 11,600 years in 45 minutes. So this is the challenge that awaits us.
Holy recent.
Spoken like a true geologist.
So we've all heard about the Bronze Age collapse, right? Well, yeah, something else we're learning more about every day, every month. But this came out in 30 some years ago. Actually, about 30 years, because 1993. What was interesting about that early 90s is that's when we really began to get some high resolution records of Holocene, not only Holocene climate change, but climate change going back, tens of thousands of years. Because, it was 92 and 93 when those ice cores from both Greenland and Antarctica had been extracted and analyzed, and it became apparent that all of the other more indeterminate evidence that suggested extremely rapid climate changes is now showing up with a great deal of clarity in the ice cores. Now, I don't know. Let's see. This is not necessarily based on ice cores, but this is definitely Holocene, talking about Mesopotamia, the North Mesopotamian civilization, and which would have been 3rd millennium BC. And those civilizations there were irrigation based. So they had built this whole vast infrastructure of canals and aqueducts and things so that they could irrigate their civilization. And so in this paper that came out in 93, it's entitled The Genesis and Collapse of 3rd Millennium North Mesopotamian Civilization. So archaeological and soil stratigraphic data define the origin, growth, and collapse of Suber or Subarta, the 3rd millennium rain-fed agricultural civilization of northern Mesopotamia on the Habur plains of Syria. At 2200 BC, there was a marked increase in the atmospheric circulation patterns and in the rainfall patterns. And this followed on the heels of a very large volcanic eruption. So what's the connection? I don't know. But these events are temporally correlated. The change in atmospheric and wind circulation, the rapid change in the onset of aridity from being relatively a moist climate, it became very arid very quickly. So after 4 centuries of urban life, this abrupt climate change evidently caused abandonment of Tel Leilan, regional desertion, and collapse of the Akkadian Empire that was based in southern Mesopotamia. So synchronous collapse in adjacent regions suggests that the impact of the abrupt climate change was extensive. So what was the nature of this climate change so this is around 2200 BC. So I think this falls right in that window of Bronze Age collapse. Am I right? What's the dating on the Bronze Age, Kyle?
It's pretty spread out last time I looked at it. I think it's
Pull it
Like
up.
32 to 43, somewhere in that range.
So this would have been post-Bronze Age. So
3300 BC to 1200 BC.
That's right in the middle of it.
So this is right in the middle. Okay.
BC, yeah. Okay.
So they're in this paper, they're addressing two understood questions that first attracted attention 50 years ago. The first is the problem of secondary state formation, or when, how, and why the pre-state societies of these regions adjacent to pristine civilizations were transformed into state-level societies. Well, I think one implication there is for that to occur, you have to essentially have one of those episodes of relatively stable climate. Because if you have agricultural collapse, if you have onset of an extensive drought, I mean, that's what pulls the plug on these civilizations, or one of the factors that could contribute in a major way. The developmental history of Sumer's northern neighbor, Subartu, they had rain-fed cereal agriculture in northern Syria. The second problem, okay, so basically here's the problem. The first problem they're asking is, how did these civilizations arise and come about in the first place? And then the second problem is state collapse, or when, how, and why stable or expanding early civilizations suddenly disintegrated. And after a period of instability, were eventually replaced by new state organization, often controlled by new economic groups. The sudden collapse of the Akkadian Empire at 2200 BC is the earliest historical example of this problem. Now, that was in 93. So the collapse of the Akkadian Empire, and obviously to me, it sounds like it's brought about by external circumstances more so. Now, there may have been internal, let's say there's conflicts or competition for resources that wasn't there previously. So yes, there could be degeneration in the social conditions stemming directly from the degeneration in natural climatic or environmental conditions. I think perhaps the limiting framework of thinking about these things in the past is that it was exclusively due to internecine or internal affairs that were going on, and that if you were considering in the larger context of environmental or climatic change, then they often were dismissively referring to that as determinism, as climate determinism. And climate determinism was considered for a long time, pretty much to be an outlying model of prehistory, but not so much anymore, because now the evidence is pretty much overwhelming that, yeah, these changes, these external changes in the climate and the environment have affected civilizations to a much greater extent than was recognized 30, 40, 50, 60 years ago. So in this article, and this was published in Science, 20th of August, 1993, if anybody wants to look it up and read in more detail about it, because it goes on with some really interesting stuff. But it's Tel Lelan, one of 3 large third millennium cities on the Habur Plain, which I could pull up on the map, but I don't think I will. This particular site occupied 70 to 100 hectares at maximum size and was dominated by a 15-hectare acropolis that today rises 20 meters above the level of the plain. It was occupied from the mid-6th century millennium BC. Tel Lelan became a major center in the mid-3rd millennium BC and the political capital of the region in the early 2nd millennium BC. So then they describe their excavations there and what they found. Let me see if I can find any good pictures of remains. Not too much, really. But yeah, so there was an abrupt climatic change that brought the whole thing to a sudden end. So it was clearly a catastrophic event. Now, whether it happened over a matter of weeks or, really, you could think of it, if it happened over a generation, that's catastrophic. Anything that happens within the framework of the human time span, certainly I think would qualify as being catastrophic. But yeah, it goes on. There's a very interesting stuff. So final in the concluding comments here, it says that the abrupt climate change that generated the Haber hiatus 1 and the associated Akkadian Ur-3 collapse are synchronous with climate change and collapse phenomena documented in the Aegean, Egypt, Palestine, and the Indus. So this was a major event in the second third of the Holocene. So that would be, in my mind, worthy of more attention to learn more about that, because it looks like whatever it was that was behind all this caused pretty much the collapse of everything that was going on around the Mediterranean. That pretty much encompasses all of the acknowledged advanced state societies, cultures, civilizations that would have been happening around the Mediterranean, and it looks like they all pretty much collapsed within the same narrow window. So, raises some interesting questions. What happened, in 2200 BC, and how much more extensive? Was it only limited to events around the Mediterranean, or was it more widespread? Did it cover a whole continent or a hemisphere, or possibly was it even global in extent?
When the starting date, he said 5300 or 3300 BC, right? So you're getting back to potential dates for the Burkle impact, which, some of those ripples we've looked at, the direction of that tsunami, could have affected the Mediterranean. And then, the Bronze Age was started up after that catastrophe.
Mm-hmm. Well, let's see. Now, here's another paper. This is a little bit more recent.
What dates did you get? Sorry, what dates did you get for the Bronze Age collapse? Because I'm seeing much more recent.
3300 to 1200 BC, I think it was.
So yeah, 3,200 years ago. What was familiar to me?
Well, what we were just looking at was 4,000 years ago.
The Bronze Age collapse, also known as the Late Bronze Age collapse, between 1200 and 1150. It was during the 12th century BC.
Yeah.
Okay, so that's 1,000 years later than what we were just talking about.
Okay.
Now, what is that suggesting? So here is the 9th century before Common Era destruction layer at Tel Es /Gath, Gath, Israel, integrating macro and microarchaeology, and that is from 2011. This appeared in the Journal of Archaeological Science, volume 38, 2011. And this is what it opens with in the abstract. Destruction events in multi-period sites are valuable marker horizons that represent time-synchronous events across the site and sometimes between sites. Now, that's exactly what we were discussing in our opening conversation that we're having, wasn't it? The idea that these events can leave markers that can be correlated over much larger distances. That's what it says here. The term time synchronous events across the site and sometimes between sites. Okay, so then it goes on to say that destruction layers often preserve rich finds that provide insights into site use. Here, we use both macro and microarchaeological methods to study a destruction event from the late 9th century at Tel Gath, or Gath, in Israel. Now get this. A major conflagration at this specific location resulted in the consolidation of parts of the roof construction materials, thus enabling us to differentiate between roof, walls, and floor materials. So that was, we touched briefly on that on the live episode. So that was, we have a major destruction event involving conflagration, happened in Israel, and this was 9th century BC, or basically 2,000 years ago. Now again, how was this just a local event or a regional event or beyond? But it says here we examine the case of a seemingly short-term violent event. The destruction of Tel Gath, or Gath, Israel, dated to the mid-late 9th century before Common Era.
Yeah, I think we discussed this before, and we were looking at pictures that they have in the paper. Yeah.
So I just basically wanted to revisit that to get the date of that.
Okay.
So this was 9th century. So this is like basically
almost 3,000 years ago, right?
9th century BC would be almost 3,000 years ago.
Yeah.
Right. Almost 3,000. And then the other one, the earlier destruction there in Mesopotamia we were looking at was about 1,200 years then before that. Okay. Now, I'm curious, what else happened 9th century before Common Era? Now, if you could find other destruction layers that correlated with that, now, of course, you can begin to reconstruct the extent of these events. Let's see. Then there's, when is this from here? This is another report from 1995. The destruction of Megiddo at the end of the late Bronze Age. Renewed excavations at Tel Megiddo planned on a long-term systematic basis in order to study the stratigraphy of the site and the material culture. Okay, so this was done under Tel Aviv University. And I haven't read this article yet, other than it gets into that there was a destruction event there that occurred at Stratum 7, and I'm trying to see quickly what the date of this was. I'm not seeing it right away, so let's see. This other one was, I found very interesting, was but yeah, so we'll add that to the list. I'm going to do some additional research here so we can report on this, because this is ongoing. This is from the year 2000. Poseidon's horses, plate tectonics, and earthquake storms in the late Bronze Age Aegean and Eastern Mediterranean. In light of the accumulated evidence now published, the oft denigrated suggestion that major earthquakes took place in the Aegean and Eastern Mediterranean areas during the late 13th and early 12th centuries BC must be reconsidered. Okay, well, now that brings us right back to 3,200 years ago, right in there, in that window. A new study of earthquakes occurring in the Aegean and Eastern Mediterranean region during the 20th century, utilizing data recorded since the invention of seismic tracking devices, shows that this area is crisscrossed with major fault lines, and that numerous temblors of magnitude 6.5 or above, which are enough to destroy modern buildings, let alone those of antiquity, occur frequently. It can be demonstrated that such major earthquakes often occur in groups, known as sequences or storms, in which one large quake is followed days, months, and even years later by others elsewhere on the now weakened fault line. So, when a map of the areas in the Aegean and Eastern Mediterranean region affected, that is, shaken by 20th century AD earthquakes of magnitude 6.5 and greater, when that is overlaid on the map of sites destroyed in these same regions during the so-called catastrophe near the end of the Late Bronze Age, it is readily apparent that virtually all of these Late Bronze Age sites lie within the affected areas or high shaking areas. The evidence would suggest that an earthquake storm may have occurred in the Late Bronze Age. Late Bronze Age Aegean and Eastern Mediterranean during the years 1225 to 1175 BC. This storm may have interacted with other forces at work in these areas circa 1200 BC and merits consideration by archaeologists and prehistorians. So this is 23 years ago when this came out. In the introduction, they point out that scholars have long noted a series of destructions datable between 1225 and 1175 BC, which are usually attributed to human actions, like we were talking about before, right? That these destructions were, pretty much exclusively the social problems or competition for resources leading to warfare and so forth.
Yeah.
What was ignored was the idea that they may have had a trigger that was outside of society, outside of culture. So he's now the authors of this. Let's see. Yeah, the two authors are with the Department of Geophysics and the Department of Classics. Okay, so these guys have teamed up. So one guy is a geophysicist and the other guy is a doctor of classical literature. So that's the kind of interesting cross-disciplinary science that can be so interesting. So they're referring to the work which I haven't followed up on, but a Claude Schaefer, who first made a suggestion that an earthquake might be responsible for those destructions in 1948. And then he wrote another paper in 1968, and it says that this was not well received by his peers, in part because these catastrophic events at the end of the Bronze Age were spread over a 50-year period and could not have been the result of a single geological event. And I think, this is kind of what we've seen even with the idea of the dismissal of an impact hypothesis for the mass extinction. Because some paleontologists have come forward and said, well, the mass extinction didn't all happen in one instant, one temporal instant where they all went dead, where they were all killed off globally, and therefore there were no cosmic impacts. I mean, that has been oversimplified, but that's been pretty much the essence of some of the attempts to negate or refute or dismiss the idea that cosmic impacts may have played the key role in the megafaunal extinctions, is because, well, we can show that the megafaunal extinctions happened over, a number of decades or centuries, or, within that range, or even a millennia or two. And therefore, it was not attributable to cosmic impact. That has been the argument. Now, but the problem with that is just like we see here. If you have this oversimplified that there's one earthquake, it's not preceded by foreshocks or not followed by aftershocks that could extend over decades even, so that by the time you have a society that, suffers one destruction, maybe not a complete destruction, but enough of a destruction that that there's obviously going to be recovery time. But before you can get fully recovered, you've got another destructive event, and you have a succession of these over a period of a generation or two. It may be enough, probably would be enough, to pretty much pull the plug on whatever was going on, right? Just makes sense. So it sort of the argument kind of got into these oversimplified terms. So the gradualists weren't ready to acknowledge the possibility of catastrophism, because basically they had this straw man image of what a catastrophic model would entail, which would be just one big event and boom, that's it, right? But if this is possible, that you've got what they're talking about here, earthquake storms, just as possible as you might have impact swarms, that there may be a period of intensified impact activity that could last several centuries, right? Now, and then, of course, that raises the question, what is the connection, if any, between impact events and seismic events? Well, we have one precedent that we can look at. The Tunguska event, which was an aerial burst, was able to trigger a greater than 5, like a 5.5 on the Richter scale earthquake. So what could actual series of events do, of impact events? Is it so outlandish to consider that there could be a correlation between impact swarms and earthquake swarms? I don't know. What do you think, Russ? While I catch my breath.
All right. No, I think that makes sense. I mean, like you said, if Tunguska can make a 5.0 on the Richter scale earthquake, then
yeah,
multiple explosions in the atmosphere, some things impacting, and that happening over a period of years would trigger earthquakes, volcanoes, who knows?
Well, who knows, right?
And then all of that would contribute to changing climate, aside from the immediate catastrophic effects.
Yeah. So this is a really interesting paper.
I did find that the Indus Valley collapsed, but not at 900, but at like 13 to 1200 BC. So that's more in line with the Bronze Age collapse.
Aha. So this article, which was, when did I say it was published? In the Journal of Archaeological Science in the year 2000. The present article surveys the available geophysical and archaeological evidence and suggests that this 50-year period of destruction in antiquity could have been the result of a series of related earthquakes known as an earthquake storm. And then the authors point out that it may have interacted with other forces at work in these areas circa 1200 BC. So the geophysical evidence, all earthquakes of maximum intensity of 7 and larger, which occurred between 1900 and 1980 in the Aegean and the Eastern Mediterranean, have been recorded by modern seismic instruments and are depicted graphically. The epicenters are easily calculated. The intensity and maximum ground motion felt at a particular location is also easily calculated. Since intensity is a simple function of magnitude and distance from the epicenter and is measured on the so-called modified Mercalli scale. So then they chart all of these earthquakes, and there's been a bunch of them, wow, between the Mediterranean and the Black Sea, up into Turkey, over into, Syria, Lebanon. But I think there are pictures here. And yeah, the archaeological evidence gets really interesting. So the archaeological evidence, let me jump here. What they found was, they found that the buildings had collapsed. They found skeletons under the rubble of the house room north of the citadel. And this is just an example of which there are many. In a house built 200 meters north of the citadel, on the lower slope of Prophetus Ilias at Placus, a building which was destroyed in the circa 1250 BC. The basements were found full of fallen stones, which covered the skeletons of 3 adults and a child crushed beneath them. In addition, the walls of several rooms were found fallen down the slope. Other walls were found leaning outwards, including one basement wall, which had tilted so much the gap was left where it had originally joined with another wall, and huge chunks of plaster, both painted and unpainted, had come loose from the walls and crashed onto the floors. House number 1 of the Panagia group, built on the west slope of the ridge north of the treasury of Atreus, destroyed violently. And quoting, the skeleton of a middle-aged woman whose skull was crushed by a falling stone was found in the doorway between the main room and the anteroom. The body was then buried by the debris of the house, which included smashed vessels and a chimney pot lying on the floor. Furthermore, the excavators noted, quote, the collapsed state of the doorway leading into the house and the condition of the south wall of room 2, where the preserved portion of that wall was found leaning outward towards the south. And it goes on and on. House 1 was suddenly destroyed. The pile of stones found all over its area, the smashed vases with all their pieces in place under stones, the lack of burned remains, the discovery of a female skeleton in the doorway of its main room with skull broken by fallen stones, all seem to indicate that House 1 was destroyed by a violent earthquake. So, yeah, it goes on, and here we go. Let's see. I'll do a share screen here. Let me find some of these interesting photographs here. Oh, yeah. Look. So here's one of the skeletons that got.
Oh, yeah.
Mm-hmm. With skeleton. Let's see. A skeleton in the background. Let's see. That's A. So let's go up here. Oh, yeah. Look at the skeleton is here. So is that the same skeleton? Looks like it. Yeah. 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 That poor fella met an untimely end, didn't he?
Yeah. If that was the one in the doorway, it was a woman, I guess.
Uh-huh. Okay. So let's see here. Tilted eastern. Okay, here we go. There's your tilted eastern and western walls within building 6. So some of the walls didn't get knocked all the way down, but they're tilted. And then apparently there has been not enough seismic activity since then to finish the job of knocking these walls down. So this goes on the basis, on many sites, actually, they're looking at here. The idea of an earthquake having contributed to the destruction of Troy, circa 1250 BC, is a matter of some controversy. However, with scholars suggesting that some of the observed damage could have been caused by subsidence and settling rather than solely due to an earthquake. On the other hand, the final report by the excavators stated that, quote, we feel confident in attributing the disaster to a severe earthquake. They believe that a violent earthquake shock will account more convincingly than any probable human agency for the toppling of the great city wall. A later re-examination by Rapp in 1982, a geoarchaeologist, further concluded that on the basis of the large quantity of loose material and the abundance of trimmed blocks in the debris, from the major destruction of Troy, I believe that the most tenable hypothesis for the cause of this destruction lies in foundation failures stemming from earthquake-induced earth movements in the underlying unconsolidated material. Interpreted thus, the evidence applied by the excavators seems overwhelming. So all of these things now, and there's a lot more, have to do with the Holocene and what's been going on in the Holocene. And I think what we're finding out is that the Holocene is a lot more interesting and dynamic, particularly now when we start looking the two parallel strands here. On the one, the history of civilization, of, the emergence of culture and society and the development of infrastructure and advanced societies, and what's going on in the natural environment. And I think we're now at that phase where we're really beginning to see the correlations there, and realizing that determinism is, in fact, the more accurate way to, and in fact, the only way that we're going to understand these events throughout the Holocene. And I think that maybe part of the reason there's this reluctance is because if we begin to recognize that there have been a succession of, well, we'll say dynamic events or even catastrophic events throughout the Holocene, what does that imply for models of climate change that are based on the assumptions of pre-industrial prolonged stability? Well, it brings all that into serious question. So I think that very possibly there's a disincentive to really to look at this and to acknowledge how dynamic the Holocene has been. And there is a whole bunch of stuff that now is in hand that you think contradicts, that you guys were aware of the fact that that was just the COP28, I believe it was, held in Dubai.
Yes.
Some of the stuff that's coming out of there, CNN is reporting on it. So CNN, here's quoting CNN, "It's time to limit how often we can travel abroad." So they're pushing now for carbon passports.
I did see that.
Yeah. "Drastic changes to our travel habits are inevitable. Suggests restrictions will be forced upon the public." So are you guys ready to sign up for your carbon passport, which tracks how much carbon you use in your movements around? I mean, that's literally what it does.
Does it track how many trees I plant, man?
Oh, man. Yeah, so they are saying that not again, this may be our last chance. COP28 talks enter the final phase. This is it, our last chance. And there were 475 lobbyists attending the COP28, most of whom arrived in private jets.
Yeah, of course.
Yeah. Somebody calculated their carbon footprint, and it's gigantic. So my point in deviating into that is that to recognize that there are natural forces at work here, that there have been extreme droughts, extreme floods, changes in temperature, all of this kind of stuff happening naturally, irrelevant to what we're doing, and we're the victims of these changes rather than the perpetrators, because the whole scenario has been flip-flopped 180 degrees. So now, rather than what history is showing us, what the data is showing us is that we, the human species, and our handiwork on the planet have been affected by these events. Are we going to, is somebody going to argue that an earthquake swarm at, 1200 BC is the result of humans' activity? Probably not. You're probably not going to convince anybody of that, right? But the point is that this is a natural thing. Now, is that correlated with other stuff, changes in the climate? We saw the one that was preceded there, the one at 3,200 years, 4,200 years ago, the first one I looked at was preceded by a volcanic eruption. Now, it didn't go into detail on the location or magnitude of that volcanic eruption, but there again, can we see that would it not make sense that if impacts are triggering seismic activity, that seismic activity could also be correlated with volcanic activity? I think we'd be idiots if we just categorically rejected that possibility. So, if there are, and that's the thing, I think that we have to really be moving towards this integrated model that everything can be affecting everything else. And up to this point, I think what the Holocene has shown us is that these natural changes have affected humans far more than the inverse of that. But now we're trying to be propagandized into believing that it's all up to our activity. And so now we've got to be issued carbon passports. I mean, that's what that's what they're talking about. They're talking about, eventually by the 2030s, they're going to be monitoring all of our carbon use. Wow.
If you do what the elites say, everything will be fine.
Right. We will own nothing and like it.
Yeah.
And be happy. That's what it is, right?
The other interesting thing that you can draw from things like the Bronze Age collapse being caused by external factors like climate or earthquakes, in other words, catastrophic events.
Yeah.
Is you have what amounts to basically a regional catastrophe. Probably it wasn't. I'm not sure if it was considered to be global, this thing that caused the Bronze Age collapse. But you go back in time and you find much larger catastrophic events, and then you can say, well, this could collapse an entire global civilization. It could destroy what was there before and do it drastically.
Yeah. Mm-hmm.
Like, it doesn't take much, and the stronger the catastrophe, the less that is left over.
That's right. Yeah. And within there's got to be a threshold somewhere. I mean, if we look at local disasters, like I think about a good example might be Hurricane Katrina when it struck. Was that 2011? When it struck New Orleans? 2005. God, okay, that long ago. Oh my God. So 2005. New Orleans is still not recovered fully from that, but what allowed the recovery of it was the fact that there was intact. The rest of the continent was intact infrastructure. Now, if you take a Katrina and just use that as your measuring stick, and you go, okay, well, we can bring in a few $1 billion worth of resources from other areas of society that are still fully functioning and intact. But what if we go an order of magnitude or more greater than that? What if we had 10 cities that all suffered the kind of degree of devastation as New Orleans did in 2005? Well, like I said, New Orleans is still not fully recovered. But if we did 10 times worse than that, and now that much resources has to be marshaled, and obviously the resource base that would be used for the recovery is going to be spread much thinner. What happens if you have 2 orders? What if you have 100? What if you have 100 times that? Where do you get to the point where, now recovery essentially has been reset almost to zero, rather than, obviously the damage suffered by New Orleans we didn't have that damage here in Atlanta. We didn't have it up, out in Houston or, wherever,
so
right?
There's a threshold. Yeah, there's a threshold at which civilization doesn't really recover.
Yeah, that's what I'm getting at.
By using other civilization. It just has to start over from scratch.
It has to start over from scratch.
Yeah.
Right. So
and maybe the other thing I thought of that with Katrina is hurricanes also come in swarms.
Yeah.
Right.
Yes, they do.
So
right.
it would be silly to look at, if you were some future archaeologist and you looked at 2 cities that were sort of distant from each other, but both on the coast, that had been destroyed in the same year by what looked like high winds and water. And you were like, well, this must have been human activity because a hurricane can't be this big. Right. Implying you don't know that hurricanes can occur in swarms. They happen over a period of time within the year, and you can have multiple hurricanes impacting.
Yeah.
Just like you can have multiple impactors, multiple earthquakes. So,
Right.
Yeah.
So this is from 2009. This is the Journal of Environmental Geology. The title is Documentary Evidence on Weather Conditions and a Crisis in 1315 to 1317. So bringing it even closer to our own time. So this is that transition now. Think about early 1300s. We're looking at the transition from medieval warm period, phasing into, this is the first phase of the Little Ice Age. So climatic conditions of the Middle Ages is the subject of several research papers, either as long-term investigations or in the form of case studies on extreme events. Being already part of the Little Ice Age, the 14th century is still considered as a transitional period between the medieval warm epoch and the Little Ice Age. And this period poses several questions concerning variabilities of climate. A number of investigators pointed out that during this century, temperatures in Western and Central Europe started to decrease. In the Alps, the Aletsch Glacier started to advance from the 1120s and reached its maximum at around 1350, which can be related to the decrease in temperature in the Alps from the second half of the 12th century to the 14th century. In this period, temperature decreased and also wet years became more frequent, especially in the Western European territories. From the 13th century, the number of climatic extremes increased in Western Europe, and so did the number of sea floods in the northwestern European region. The second decade of the 14th century gained special attention among climate scientists. Now, this is something that we actually can now buttress this insight from all kinds of evidence that the transitions from warm to cold, that encompasses some of the greatest climatic extremes now in the record. The transitions from cold back to warm, but not nearly so much as the transitions into the cold phases. So the 1310s was the decade in which multiple years without summer occurred. In the mid-1310s, a serious famine took place all over Europe. In England, for example, unfavorable weather conditions started from 1314 with precipitation increase and temperature decrease. According to Emmanuel Leroy-Ladurie in 2004, in the year 1316, 3 million people died because of the lack of food. Now, this, of course, is coming right on the heels, like within a decade of 300 years of warm climate that saw, like we've talked about, the proliferation, the growth of society, the extension of human lifespans, the enlargement of human stature, the decrease in infant mortality, and the enough wealth and riches in resources that they could build all of the great Gothic cathedrals.
Yeah, the cathedrals.
And is it any coincidence that the end of the 1200s is when you see this incredible phase of cathedral building pretty much ending? Exactly when the climate shifts from medieval warm to what would happen? What would 3 million people do to the labor pool in Europe? 3 million people dying of starvation. Now, if you have 3 million people dying of starvation, that doesn't mean that the rest of the people were fat and happy. No, they're probably suffering through it. They survived, but you can see right there what's going to happen to the labor pool that's now engaged in undertaking all these magnificent enterprises like the cathedrals.
And an apparent loss of some technical skills too, right? Isn't there glass in some of those cathedrals that nobody is sure how it was made? So even that, the cold and the famine results in a loss of technology.
Yeah.
That still hasn't been recovered.
Yep. So then this is from another seminal work by Jean M. Grove, who actually wrote a whole book on the Little Ice Age. And I think her stuff was sort of, or yeah, no, I don't remember now. Anyways, I read the book years and years ago, probably 30 years ago. But then I got these quotes are from that book. And so this is, again, 1988. And the author, Gene M. Grove, is saying, quote, "The common behavioral feature of nearly all the world's glaciers is their recession over the last 100 years or more." So really, as we've talked about, the glaciers, the swollen glaciers of the Little Ice Age began receding a century before any significant fossil fuel contribution to the atmosphere via human activities, okay? So that's important. Again, a fact that's generally ignored in all of this discussions. Okay, the exceptions are relatively few and can usually be explained in terms of special circumstances of some kind, such as the occurrence of unusually heavy debris cover on ice tongues or exceptional accumulation conditions. However, the scale and ubiquity of the recession is comparable with that of the advance that seems to have taken place in so many parts of the world. And that was the author's referring to the second phase of the Little Ice Age, which occurred around 1600 and lasted for about 250 years. Okay, these events can be seen at this distance in time as bracketing the Little Ice Age. The importance of the climatic factor in history has been minimized by some 20th century historians and historical geographers. They have been working in the more prosperous parts of Europe and America during a period when history, like many other fields, has become more specialized. And moreover, in a period during the first half of the century when climate was somewhat more benign and dependable than it had been earlier or has been since. The broad overview has not been fashionable, but such synthesis is needed. Technological advance and sophistication of the economic structures of society provide important buffers against the immediate impact of climate. Now, this is an important point right here. I'll say it again because it's extremely important. Technological advance and sophistication of the economic structures of society provide important buffers against the immediate impact of climate. And in this case, we could say climate change, right? So now, if we consider that we are going to adopt a series of strategies, economic and social and cultural and scientific strategies, industrial strategies that are based upon the assumption of a steady state society, that a steady state climate that's only affected by human activity, as opposed to a model that now recognizes that it's an extremely dynamic climate totally on its own and is going to continue to be that way regardless of what we do. What's going to happen? We have to now look at what kind of technological advance and sophistication is going to allow us to provide those buffers or to compromise those buffers. And I think the conclusion that is becoming really overwhelmingly apparent is that the kind of remediation measures now being proposed would mitigate the effectiveness of bumpers against immediate impact of climate change and leave us more vulnerable to the kinds of things that are going to happen naturally, irrespective of what we do and whether we adopt, carbon passports or not. Is the climate now going to quit changing if we adopt carbon passports? Now, buildings can be going on here. Buildings can be heated, roads and railways kept open, and foods in short supply imported from elsewhere, so long as these are available. Although Western Europe and North America are currently in a position of surplus food production, deficiencies exist elsewhere. The agricultural revolution since the Second World War, generated by plant breeding and selection with increased use of fertilizers, led for a time to the assumption that the weather changes were no longer of importance. This complacency was shaken by the severity of the cooler years of the 1970s. Now, this is very important because a lot of younger people who do not remember, who were not around during the 1970s, don't remember the scare about the possibility of a little ice age. And as I've explained, there was actually more merit and credibility to the fear of a little ice age than there is to the fear of global warming. And there was two reasons for that. One, in the 1970s is when we came up with the evidence that these climate changes had been extremely fast, in the past ice ages, that things happened in, a century or a few decades or even literally a few years or less, right? And so we've now realized that the length of a period equivalent to the Holocene in the record, we don't have any evidence of anything going much beyond 10,000 years, right? I even have a quote here. I think it's coming up in a slide where they're talking about exactly that. Okay, so the problem then is, we're going, well, wait a second, look at these previous periods of time that we thought were tens of thousands of years long that were equivalent to our own. Well, it turns out they're way shorter, way more brief than we had thought they were. In fact, look at the longest we see prior to our own now is roughly 10,000 years, and we've exceeded that probably by a millennia or two. Now, at the same time, that 1930s, 1940s climatic warming that came right in the wake of the ending of the Little Ice Age, that was coming to an end. And you can actually look at the climate data and you see that the trend line is going up from the early 20th century right up until the late 60s, early 70s. It then goes down until the late 1980s. So there's another important point here. When we look at so much of the baseline of the modern global warming predictions, they go back 30 years. So you go back 30 years, you're now in the you're in the early 90s. Okay. So now what's happened? You've come to this, you've gone right back to this point where the trend line, that inflection point, where the trend line, which has been going down from the 1970s through the 1980s, it's now trending back up again. So if you went another 20 or 25 or 30 years before 1990 or the late 80s, well, what you're then going to see is the cooling. But by clipping that record in the early 90s, now all you get is an upward trend. You see, and it's deceiving. It's not a real depiction of climate change on a long enough scale of time to make sense out of it. So it goes on here, referring to the cool years of the 1970s. And of course, it turned out that the fear of the return of a little ice age was unfounded at that time. However, is it unfounded to completely, is it worthy to completely dismiss the idea of another phase, let's say a phase 3 of the little ice age? Because what would happen is another phase of the little ice age where we have, multiple, say, years without a summer. Presently, yeah, we could weather that. We could. But some of the measures that are being proposed are going to make it a whole lot more difficult. If we're preparing society for what we think is going to be a warmer world, and we go back into a cooler world, well, see, we ain't going to be prepared for that. So this is what it goes on. It is now recognized that the more efficiently farming is organized to make optimum use of normal weather conditions, the more sharply production is likely to fall if the climate deviates markedly from this assumed norm. If crop varieties are bred to thrive in a narrow range of temperature and moisture conditions, they may give poorer yields than their predecessors if the actual conditions are outside this range. It is the climatic implications of increased carbon dioxide concentrations in the atmosphere that currently exercise most of the climatic community. And of course, what was true in the late 80s when this was written is way more true now, right? But here's the point that the author goes on to make, and this is the important point. And I don't know whether this is true or not, but it certainly, as it says here, is a possibility. It is possible that such man-induced changes, like a warming caused by increased amounts of carbon dioxide, it is possible that such man-induced changes helped to bring the Little Ice Age to an end, and that the global rise in temperature since the middle of the last century has been caused by these increased concentrations. The fact remains that a small but distinct temperature fall affected large parts of the globe in the 1960s and 1970s, but this occurred despite increasing carbon dioxide concentrations. So now we have several things to think about there. Think about this. Right after World War II, when car culture spread and urbanization spread, and there was a huge uptick in the amount of fossil fuel consumption coming out of World War II, that then, of course, led to the introduction of large amounts of carbon dioxide into the atmosphere. That occurred at the end of and in the post-World War II environment. Nobody, not even the most hardcore promoters of global warming, maintained that prior to World War II there was enough human-introduced carbon dioxide in the atmosphere, only because the fluctuations that had been the pre-industrial fluctuations, there was evidence to show that those pre-industrial fluctuations in ambient concentrations at least equaled, maybe exceeded the shift in carbon dioxide concentration as a consequence of burning fossil fuel. So basically, post World War II, now we've got all of this, the carbon dioxide is going up. We'd think that at that point, we should also see a corresponding warming, but it's not what we see. What we see is exactly when carbon dioxide went up for the first quarter century, temperature was cooling. Now, that's never been explained. Okay. Then obviously, apparently, there's not a one-to-one linear relationship between increase in carbon dioxide and increase in temperature, right? But that's another one of these facts that's conveniently ignored. Anyways, this cooling was, as we have seen, this cooling during the 60s and 70s was sufficient to have marked biological effects and to influence agricultural production in high latitudes, and even to have political consequences. A reversion to the climatic conditions of the Little Ice Age is perhaps less likely now than it would have been, but for the burning of fossil fuels over the last few decades. But it might be wise not to assume that a return to Little Ice Age conditions is entirely out of the question. And one could, and I think, didn't we look at some slides recently looking at some of the previous warm periods? We did look at a slide, didn't we? Showing the average near-surface temperature of the Northern Hemisphere during the past 11,000 years.
Yeah.
Yeah, we did. So I don't need to pull that up again. But what you saw was that the modern warm period was maybe not even as warm as the medieval warm period.
Right.
Which was not as warm as the Roman climatic optimum, and certainly not as warm as the Holocene climatic optimum, which happened in two phases. And yeah, so that was a very interesting period of time, is that Holocene warm period.
Well, we got to wrap it up here for tonight, Randall.
Oh, but I'm just getting warmed up.
You're just getting started?
I'm just getting started.
Randall warming?
This is, yeah.
It's a hockey stick, and bam, right at the end, shoots up.
Well, so what we'll do, I want to get into talking about some of these guys like Hubert Lamb and Herman Flown, and we've talked about them before, but, they were the guys who basically founded the modern science of climatology, and they were the ones publishing and doing their research before the whole issue of climate change and global warming became politicized. So it's very interesting to look at what they had to say back 25, 30, 40 years ago, what they were learning in the 80s and the early 90s and things, and then address the questions of the modern warming narratives in the context of what they were saying before the science was being contaminated by politics.
All right. Sounds good.
And by the way, Jean Grove was a British physical geographer and glaciologist known for her comprehensive study of climate change in the Little Ice Age across the world.
Yes.
I just want to note what you were saying about the so-called cooling trend of the 70s. I do remember those articles. They weren't fringe articles. Newsweek, Wall Street Journal,
right?
The major publications were running articles on this idea of global cooling. Concurrently, there was speculation. There were articles about the coming population crisis, facing imminent starvation. Food crops.
I remember
that agriculture was not going to be able to keep up.
Right. I remember reading books like The Population Bomb,
right,
by Paul Ehrlich,
right, and
getting kind of freaked out about it, but then I kind of forgot about it because I had more important things on my mind,
right.
You think that was just it seems like it could have been just a learning that they learned oh, this is powerful. We can scare people with this and get things done.
Well, that's an interesting thought.
There may have been, like you were saying, there may have been some evidence for possible global cooling. It didn't end up happening, but it was some legitimate science. And then they saw how freaked out it made people, and they're like,
sure, what? Yeah, hell yeah.
I mean, that's my conspiracy guy coming out.
Well, a conspiracy guy might actually be onto something, because they've certainly incorporated. I mean, if you look at the mechanics of propaganda, you can see it's all being invoked and wielded for the global warming thing.
Yeah.
And they've got now a whole generation of kids come up that don't have much more than a couple of decades of perspective. And so, old farts like me and Mike, we've been around long enough to know that, well, wait a second. How different is it now than it was when we were kids? There were cold days, there were hot days, there was all kinds of stuff going on. But, if you don't have any long-term perspective, you might easily be led to believe, like so many younger people now, not the millennials and younger, is that, what is there a new term, right, for the ones that are now coming of age?
What, the Zoomers?
The Zoomers.
Gen Z?
The Zoomers. Oh, yeah. Me and Mike, we're boomers. The Zoomers are what?
There's boomers, and I don't remember. Then
I can't keep up.
You get to Gen X, then you get millennials. I'm a Gen X. Kyle's a graybeard millennial. He's at the very earliest millennial. And then after that is Gen Z, I think.
Gen Z.
The Zoomers.
The Zoomers. Okay. Well, so a lot of those Zoomers are really getting hysterical over, they're like, I turned on NPR a few days ago, and I guess I won't get into a big diatribe because we got to go. But they're on there. What they're doing is they're interviewing all these young ladies in their early 20s who've decided not to have children because of global warming, because of climate change.
Yeah, they think that the world will not be able to sustain them or their kids. I have seen this. Yeah.
And they've been, because they've been brainwashed.
Yes, they've been fed a constant stream of doom porn in school. Yeah.
That's it. Yep.
I like that. Doom porn.
It's doom porn. Straight up.
Well, that's something that, it's worthy of further discussion, because, things are going on right now that I think completely, are going to completely, if not suppressed, launch us into an entirely new era of resource utilization. That renders all of these old models, the Malthusian-based older models, going back to, the population bomb and all of that, just basically rendering those completely irrelevant and obsolete. But
the Zoomers don't have anything to worry about, because according to the proceedings of the National Academy of Sciences, the Little Ice Age was caused by warming. So we'll be all right, folks.
So the global warming is going to cause global cooling, and everything will be fine.
That's right.
Cool.
Okay. As long as we don't succumb to famine in the process, right?
Right. No, it can't get hot, Randall. That's dangerous.
But we should talk about the upside, which is constantly being confirmed every day, with agricultural surpluses. Except that, you saw the
Well, we have discussed it, like the greening of the planet, more CO2, like longer warm periods is, you have wider food belts. Yeah.
Well, you yourself said here, a number of episodes back about greenhouses.
Yeah.
And, ramping up the concentrations of CO2 in a greenhouse. What does that do to the productivity of the plants?
It massively increases
it. Kills them.
Well, yeah, I mean, up to a point, there's some point at which the carbon dioxide would be too much. But considering that in most of Earth history, it's been 2 and 3 times or 4 times higher than now, I don't think we're at that threshold where we need to be worrying about we're going to die of carbon dioxide poisoning like what happened to that lake in Cameroon. You remember that?
Oh, yeah.
When there was that volcanic eruption and it spewed out, and that's an interesting story in itself. Now, that's what's happened when you get up to like 10,000 parts per million or something.
And we've done that in our winery, and it is can be disorienting.
Oh, you have? So what were you doing? Was this a scientific test?
When you're fermenting, and especially when you have a bunch of very large vats in a small-ish base, and it's fermenting, it's making tons of CO2. So I brought my CO2 meter there so that we could read the concentrations in the winery, because it can get really high. And many times the meter would just give an error, and that error happens when it's 10,000 ppm or above, right? It can't tell you. And yes, you would get lightheaded and you had to go outside. Can't stay in there long. Yeah.
This last year, I couldn't even hardly walk in there.
Yeah.
I had to, go in just long enough to open the door, the big bay door. Right. But it was just,
yeah.
But you can
alcohol
test
fumes as well. Doesn't help.
Yeah. Right. And, but you've been in greenhouses that were 1,100, 1,200 parts per million.
Yeah. Yes.
And you were just fine.
Right. You don't even notice.
Just fine.
Yeah.
Right.
Well, even in the winery, when it was down at like 4,000 or 6,000, it was fine.
You're okay. But once it gets upwards of 10,000, you start to notice. Yeah.
And that number is, completely and totally unrealistic as far as,
atmosphere.
How many
it
tons
was still cold in the winery. Just like it didn't get really hot.
Well, if you'd stayed in there, what did you measure to see what wavelength of radiation Kyle was emitting?
Right.
If he was, maybe he wasn't emitting the long enough
proper
wavelength,
right,
to get trapped. Oh, you're going to need to do that next time to make this scientifically viable.
Okay.
Well, it was fun, guys.
Yeah, great show.
That was great.
Yeah, I learned a lot about the sun. Coming next time. Yeah, great stuff.
Well, the final thing, since you said that, Brad.
Oh, no, Brad.
Now what role? Yeah, the role of absolutely implicit in everything we're talking about here. The sun is also part of that integrated model, a big part of it. So
it's out there every day.
Yep.
Always on fire.
Okay.
Yeah.
All right, guys.
RandallCarlson.com. Sign up for the newsletter. Check for information on tours. There's everything you need there. All the Randall you can handle. All right, guys?
Yeah.
Yeah, this show will come out 4 months from now, so hopefully people will have figured out that HowTube is back up.
Okay.
Ouch. Not true.
I'm sorry.
All right. Good night, guys.
Yeah.
Okay.
Good night.
Good night.
Way late.
Thanks.